Hope you're having a good day, and thanks for studying math with me. Today's topic is factoring. The first thing you do in a factoring problem and the last thing you do in a factoring problem is factor out the common factors. Now this is actually the distributive property reading from right to left depending on how you write it. And so here's the first example. We observe that in this binomial there's a common factor of 6a squared. So if I pull the 6a squared out, I'm left with 1 minus 3a squared. Similarly, if I look at this one, there's a common factor of 7 across each of these three terms, a common factor of x squared, and a common factor of y squared. So if I pull that out, what I'm left with is 2x squared minus 4y plus 3. Sometimes the common factor contains, like this one does, a binomial itself. Each term has a factor of x minus 2 in addition to having a factor of 2. So if I pull out 2x minus 2, I'm left with this expression, x minus 2 squared and x minus 2, and then just a 3 as the last factor, as the last term in the second factor. We also have a process called factoring by grouping. Here, when we have, for example, two terms, so what I'm going to do is group the first two and the last two, call that single underscored, this one double underscored. I'm going to pull an r squared out of the first one. I'm left with r squared times s plus 3. I will take a minus 5 out of the second. And when I take a minus 5 out of each of these terms, I'm left with minus 5 times s plus 3. The s plus 3 is a common factor, and so the first and last thing I do is factor out the common factor. So I have s plus 3 times r squared minus 5. Again, factoring by grouping. Here, we can pull a m squared out of the first two terms, and out of the second two terms I can pull an n. So I'm left with m squared times 4 minus n plus n times 4 minus n. The 4 minus n is a common term. I'm left with m squared plus n times 4 minus n. Here's a little bit more involved example of factoring by grouping. Again, out of here I can pull a 3 out of both of those terms, 3y squared, and here I can pull out a 2, and so when I pull a 3y squared out of here, I get 3y squared times 3y minus 5, and out of here I pull a 2, I have 3y minus 5. The common factor is 3y minus 5. I factor that out, and I'm left with 3y squared plus 2 times 3y minus 5. Now we're going to talk a little bit about factoring trinomials. Now one approach is called guess and check, but many students are not good guessers, and so what I'm going to do with these is show you a different, more complete technique that really doesn't require much guessing. So I will start with the trinomial. I'll take 5 times minus 12 to get minus 60. The sign comes with. So I want to say, how can I get minus 60 as a product and have a middle term such that these add up to plus 4? This clearly does the trick, minus 6 and plus 10. So what I'm going to do is rewrite the middle term in the trinomial as the sum of these two numbers. And that's going to then change the trinomial into a four-nomial. And from here on we group factors. So I will single underscore here, double underscore here. I will take 5z out of this. I will take minus 6 out of that, and get this expression, and z plus 2 is a common factor. And so I'm left with 5z minus 6 times z plus 2. Now a factor that polynomial that cannot be factored is called prime. We can run across this sometimes. Let's look at this example of a trinomial. So the 12 times minus 3 is minus 36. So if I pick minus 9 and 4, that satisfies my constraints. I rewrite the middle term as the sum of those two and change the trinomial into a four-nomial accordingly. Out of here, the single underscored, I will take a 4t. Out of this one, I will take a minus 3, and I will get a common factor of 3t plus 1. So the answer to this problem would be 4t minus 3 times 3t plus 1. Now, when I look at this problem, I'm going to multiply across and I will get a positive 48. When I look at all the possible factors of 48, I see that none of them add up to minus 15. So I will declare this one to be prime. Sometimes you have to do, or it's simplified anyway. If you factor out the greatest common factor to start with, if I look at this, I can see that there's a 3 in all of these terms. So if I factor that out, I have this expression, 3 times 8x squared plus 14x plus 5. Multiply across, I get 40. To make that into 14, that's going to be plus 4 and 10. I write this way. I do not throw away that 3. But now I can group factor single underscored and double underscored. 4x comes out of this, and 5 comes out of this one. And so what I will have is 2x plus 1 and 2x plus 1. I'm taking a 5 out of that, so I can leave the 3 there. This is going to be 2x plus 1. I will pull out on this side. I'm left with 4x plus 5. These are things that we learned in factoring. We can apply these to situations where we observe the pattern. So here I see that this is 7x whole squared. This is twice the product of the middle terms, and this is going to be 2y, so this can be factored this way. If you don't see that, you can do it other ways. Here we have a similar thing. This is going to be 9ab whole squared. This is going to be 5 squared, and this is twice the product of the middle terms. And so what I get is this is 9ab minus 5 whole squared. Another identity that we will exploit is a squared minus b squared. This is a plus b times a minus b. So here I have 8r squared minus 7 squared. So that will factor into 8r plus 7, 8r minus 7. Here I have 13u cubed squared, and here I have minus 12v squared whole squared. So this will factor into 13u cubed minus 12v squared, 13u cubed plus 12v squared. Here, again, I have something squared minus 4w squared, so this can factor in this way. In this problem, I recognize a pattern that this is going to be x plus 9 whole squared minus 25y squared, and 25y squared is 5y, so this is going to be x plus 9 minus 5y, x plus 9 plus 5y. Here, I can observe that this, if I take the minus sign out, this is going to be y plus 5 whole squared. So this is 2y, or 2x rather, whole squared. This is y plus 5 whole squared is the difference of perfect squares, so it can be factored in this way. 2x times 2x will be 4x squared, and here's my negative y plus 5 whole squared whenever I multiply it through. The last identity that we're going to talk about is the sum and difference of perfect cubes that are shown up here. Again, in this class, those should be committed to memory, so we can recognize patterns. Here we realize this is 10 cubed plus t cubed, so this is going to be factored in this way. Similarly, this is r cubed minus 2s whole cubed, and that will be factored in. This way, actually this should be a 2. And last but not least, we can recognize that this can be viewed as the difference of perfect cubes, and I can factor it in this way. The final technique that we talk about is called use substitution. It's a big deal in calculus. Here we observed that we could let u equal 3x plus 1, and that makes it look like this. I can factor that. 8 times minus 25 is minus 200, and so that's going to be 20 and minus 10, so I can factor it this way. And then I can do group factoring, and I will get this, and then I can substitute back what u was in the final answer, and I've done that factoring by substitution. The next example is I'm going to let u be m squared, and I realize I can do that because this is to the 4th power, that is to the squared power, and that is to the 0 power. So this is the same thing as 15 u squared minus u plus 6. Now that times that is going to be plus 90. Let's see. That was a minus 6, so it's going to be a minus 90. Thank you. And that is going to be 9 and 10. That is negative. That is positive. So this is going to be 15u squared minus 10u plus 9u minus 6. I will take a 5u out of this. 3u minus 2. I will take a 3 out of this, and this is 3u minus 2. So this is going to be 5u plus 3 times 3u minus 2. And so substituting back in, this will be 5m squared plus 3 times 3m squared minus 2. And that's the way it goes with factoring. Remember, time is precious. Each day must count. Do the math. It will make you strong. Take care.